Good afternoon, ladies and gentlemen. Let's talk about anti-differentiation part 2. Yesterday we began finding some antiderivatives. But now we're going to pose a bit of a problem when finding antiderivatives. And this problem becomes apparent if I take the derivative of these three different functions. I have the function 3x squared plus 7, the function 3x squared plus 18, and the function 3x squared minus 17. The derivative of each of these functions clearly is 6x. The derivative of 3x squared plus 7 is 6x. The derivative of 3x squared plus 18 is 6x. And the derivative of 3x squared minus 17 is 6x. That poses a problem if I'm asked to find the antiderivative of 6x. The most general case would f of x would be 3x squared. But we can clearly see in the three examples above that this is not all of the antiderivatives, all the possible antiderivatives of 6x. That's just one. And it's easy to see that it's one. If I find the derivative of this, I get 6x. But let us not be led astray by this fact. What we have to do when we're finding antiderivatives is we have to take care of this situation that deals with these constants. And we have a specific name of those for that constant, and we're going to call that the anti-differentiation constant. And that gives us, if I want to find the antiderivative of 6x, I use my formula to find the antiderivative of 6x, which is 3x squared, but I have to add this constant k. And this gives me the family, what we call the family of antiderivatives. This is the family of antiderivatives. That gives me all of the antiderivatives of 6x. So let's do a problem that asks us to find a specific f of x given a couple conditions. So here's our first problem. Say we have this particular problem. Let's get this guy out of the way here a minute. Put him down there. Say we have this problem, f prime is 2x plus 7, where f of 0 is equal to 3. This is going to be called an initial condition for our problem. So we have two conditions for our problem. We have the fact that f prime is 2x plus 7 and f of 0 is equal to 3. Those are my two conditions, condition 1 and condition 2. And the problem is to find the specific f of x. So I start with f of x as 2x plus 7, or f prime of x is 2x plus 7. I anti-differentiate it, and I see that f of x is x squared plus 7x plus k. Here's my constant of integration. We cannot forget that. And I could easily work in reverse to find the derivative. The derivative of x squared is 2x. The derivative of 7x is 7. So we know that this is the family of antiderivatives. But now I'm going to use this second condition. I'm going to use the fact here that f of 0 is equal to 3. And wherever I see 0 in x and f of x, wherever I see x and f of x, I'm going to put 0, and the output is going to be 3. So I'm going to put 0 in for x squared and 0 in for this x. That will give me 0 squared plus 7 times 0 plus k is 3. And that's certainly easy to see that k is equal to 3. And I'm going to use this fact then to find the specific f of x. The specific f of x in this case is x squared plus 7x plus 3 for this particular problem. Let's go on to a bit of a more difficult problem. Here is my condition. Here's my problem. I want to find f of x if f double prime of x is equal to 3x minus 2, where f prime of 1 is equal to 4 and f of 2 is equal to 3. Keep in mind, my objective is to find f of x such that these two statements here are also true. Step 1 is to find f prime by anti-differentiating f double prime. So what I'm going to do, to get from this step to this step, I'm going to add 1 to this exponent. I have 3x to the 1. 1 plus 1 is 2. Divide by 2. And I have 3x squared over 2 minus, we know the antiderivative of 2 is 2x because the derivative of 2x is 2. And I can't forget this constant in integration. So this is my first derivative. This is f of x. What I'm going to use now is the fact that f prime of 1 is equal to 4. So wherever I see x in f prime, I'm going to put 1, and the output will be 4. So let's do this very carefully. Let's put 1 in here. I have 3, 1 squared over 2, minus 2 times 1, plus k is equal to 4. Doing some 5th grade arithmetic here. I have 3 halves minus 2 plus k is 4. 3 halves minus 2 is negative 1 half plus k is 4. Add the 1 half to both sides. That tells me that k is equal to 9 halves. This tells me that f prime is equal to 3x squared over 2 minus 2x plus 9 halves. This is f prime. Keep in mind what I wanted. I want to find f, so what I'm going to do is anti-differentiate f prime to get f. Again, I don't forget my rule. I take this 2, I add 1 to the 2. So I have x to the 2 plus 1 is 3. I divide that by 3. Keep in mind I did have this 3 halves. I keep this constant out in front. And I think it's clear that the antiderivative of 2x is x squared, or 2x squared over 2. The antiderivative of this piece, 9 halves, is 9 halves x. And I cannot forget this constant of integration. So let's clean this function up a little bit. Let's cancel the 3's. And I have 1 half x cubed, cancel the 2's, minus x squared, plus 9 halves x is equal plus k. So this is my function, and now I'm going to use the second condition given, was that f of 2 is equal to 3. So wherever I see 2, wherever I see x and f, I'm going to put a 2, and the output will be 3. So I'm going to put, this is going to be f of 2 will be 1 half 2 cubed minus 2 squared plus 9 halves times 2 plus k, and the output will be 3. Easy to see, this is going to be a nice problem. 1 half times 8 is going to be 4, minus 2 squared, minus 4. 9 halves times 2 is 9, plus k is 3. And I think it's easy to see that k will equal negative 6. That gives me the function f of x is equal to 1 half x cubed minus x squared plus 9 halves x minus 6. And again, I can check my answer by differentiating f. This gives me f prime. Differentiate f prime to get f double prime, and this is the function, the second derivative that I started with. You can always pause this video. You might want to watch this a couple times to get all the pieces down. Thank you very much.